What we're going to do is we're going to look at multiplying rationals. We've done multiplying rationals before. You have something where you have 2/3 and you're timesing it by 6/7. And so what we do is we see what we can cross cancel. 3 goes into 6 2 times. 3 goes into 3 1 time. And then we multiply across. 2 times 2 is 4. 1 times 7 is 7. So that's multiplying rationals. What we're going to do is we're going to do it with polynomials. And so when we're doing it with polynomials, the key thing is factoring. So when we're looking at the numerator for the first one, x plus 5, there's nothing we can do to factor it, so we just bring it down, x plus 5. Now when we're looking at the second one, notice that we have x squared minus 3x. We're going to look for a GCF, and they have an x in common, and that gives us an x minus 3. Then what we're going to do is we're going to multiply that. Now for our second fraction, this is a special factoring pattern, so it would be x minus 3 and x plus 3. The denominator, it's a trinomial, so we're going to use the x method, two numbers that multiply together to give us negative 12. Add up to negative 1, that would be negative 4 and 3, so we have x minus 4 and x plus 3. Now what we're going to do is we're going to cancel. We see that we have the x plus 3's in common. We see x minus 3's in common. So what we have is x plus 5 over, and then we have an x, and then an x minus 4. And that right there would be our answer. For the second one, we're going to do the same thing. So when we're looking at this, we see that we have a special factoring pattern, x minus 11 and x plus 11, because we know we can take the square root of both of those. With the denominator, we see that they have a GCF, so they have a 2x in common, so we factor out a 2x, and what's left over is an x plus 1. For the second fraction, we see that they have a 3x in common, so we factor out a 3x, and they have an x minus 3. And then we have a trinomial, so we're using the x method. Two numbers that multiply together give us 33, add up to negative 14. We know that both of them have to be negative because a negative and a negative is a positive. And that would be negative 11 and negative 3. So that would be x minus 11 and x minus 3. Now what we're going to do is we're going to cancel. We see that the x minus 3's cancel. We see the x minus 11's cancel. We see that the x's cancel. And so we have a 3 and then an x plus 11 in the numerator. In the denominator, we have a 2 and an x plus 1. For our third one, once again, our key is factoring. If we look at this one, we see that they have a 3 in common, but after they have the 3 in common, we also see that there's a special factoring pattern. So it's going to be 3 and then x minus 1, x plus 1. For the denominator, two numbers that multiply together give us 1, add up to 2, and that would be 1 and 1. So we have x plus 1, and we could put x plus 1 squared. I like to put x plus 1 and x plus 1 because I'm probably going to end up canceling one off. So it makes it easier for me to know what I actually have and what I don't. Now for the second one, it's a little bit more difficult because we've got our leading coefficient. So I'm going to multiply the 3 and the 1, and that gives me a 3, adds up to 4, which would be 3 and 1. Because the leading coefficient is 3, I divide each of these by 3, and I get my two binomials. 3 divided by 3 is 1, so x plus 1. And then this becomes 3x plus 1. For the next one, two numbers that multiply together give me a negative 6, add up to negative 5, and that would be negative 6 and 1. Because the leading coefficient is 3, I divide each of them by 3. So that would be x minus 2 and 3x plus 1. Now for the fun part, we get to cancel. And so when we're looking at the canceling, what we have is x plus 1's, x plus 1's again, 3x plus 1's. And so my answer is 3. x minus 1, and x minus 2. Pause the video and see if you could do those 3 on your own. So looking at these next 3, with this one right here, this would be the same thing. The second term would be similar to having a 1 underneath it. We know the x squared cannot be factored because it's a monomial. With our binomial, we see they have an x in common, and that would be an x minus 5. Trinomial means 2 numbers that multiply together give us negative 20, add up to negative 1. That would be negative 5 and 4. So that would be x minus 5 and x plus 4. Now I'm going to see what I can cancel. I see x minus 5s can cancel. I also see that the x and the x squared could cancel. Remember, x squared would be like x times x, so one of the x's would cancel. So we're just left with 1x. So we have an x and we have an x plus 4. And there's nothing in the denominator, so we're just going to box that answer. For the next one, we're going to do some more factoring. We have a trinomial. 2 numbers that multiply together give us 18, add up to 11. And that would be 2 and 9. So we have x plus 2 and x plus 9. And then the x plus 2 squared, that would be just the same thing as x plus 2 and x plus 2. I like to write it out just so I know if I cancel something, I don't get lost. For my second term, they have an x in common, and that's an x minus 9. And for the denominator, that's a special factoring pattern, a difference of squares, which would be x minus 9 and x plus 9. Now for the fun part, we get to cancel. And so with the canceling, they have an x plus 2 in common. They have an x plus 9 in common. They have an x minus 9 in common. Oops. And so that gives me an x and an x plus 2. And for our last one, what we have is a 2. If we factor out the 2, we see an x squared minus 4, which is a special factoring pattern. So I'm going to factor out a 2, and that would be an x minus 2, x plus 2. Double factoring. I have a leading coefficient, so I'm going to multiply those. 2 numbers that multiply together give me 4, add up to 5, would be 4 and 1. Since the leading coefficient is 2, I divide it by 2, and I get x plus 2 and 2x plus 1. For the numerator on the second one, 2 numbers that multiply together give me 9, add up to 6 would be 3 and 3, so that would be x plus 3 and x plus 3. And for my other one, I notice that they have a 2 in common. So if I factor out a 2, I get x squared plus 5x plus 6, almost said 12. So that would be 2 numbers that multiply together give me 6, add up to 5. That would be 2 and 3. So I make sure I keep the 2 on the outside, and then I have an x plus 2 and an x plus 3. Now for the fun part, I get to cancel. And so I see the x plus 2s, the 2s cancel. I see the x plus 3s, and that looks like it. So what I have is an x minus 2. I have an x plus 3. I have a 2x plus 1, and I have an x plus 2.